Hello and welcome to the architecture room. It is time to start our next talk, Shrek, Onions and Architectures. Please give a warm welcome to Katy.
Hello, everyone. This is probably the biggest screen that I've ever been this close to in my life, so bear with me as I try and dodge out the way of my slides. Thank you for coming. As was said, my name is Katy, and I am a PHP developer, and for the past 6 years of my life, I've been working on what people like to call big legacy monoliths. So at my previous company, we had a big legacy monolith that people wanted to get rid of, but obviously you don't just make a monolith go away. And at my current company as well, Personio, there is also a big legacy monolith that people hope will go away, but of course it's never going to go away. So one day I was just sat there working and trying to clean up my big legacy monolith, and I thought to myself, you know what, these systems are really misunderstood. And you know who else was really misunderstood? Shrek. And as he explained to Donkey, that actually ogres are a lot more complex than you would think, because they're like onions, okay? They have lots of layers. This is an onion. As you can see, if you cut it open, it has lots of layers. And then we look at an application architecture, and again, it has loads of layers, right? So I was sat there thinking, hang on, is my monolith actually an onion? And I determined yes. Various reasons why, yes, in fact, a monolith is an onion. Not least because there are many layers. It smells, or at least your engineers act like it does. If you just bite into it without preparing yourself, it's going to taste pretty strong and you're not going to like it very much. And also, it makes you cry. So I was thinking, how can I make people like these big legacy monoliths a little bit more than they already do? And onions are actually something that I'm quite familiar with, because my hobby outside of programming is gardening, and one of the first vegetables I ever grew was onions. So I actually know quite a lot about onions, how the botany of an onion works and how they grow and how to harvest them, and I also know a lot about legacy monoliths. So today we're going to put these things together, and we're going to talk about what an onion is, what it looks like, what the layers of an onion are, and hopefully that's going to demystify the architectural layers of your big legacy monolith. Then we're going to look at how onions grow, and by this I'm talking about how we build our systems and what makes our systems so robust. And then, last of all, we're going to talk about cooking onions, which is, how to prepare onions so that they don't taste horrible like they would if they were raw. First up, we're going to talk about the anatomy of an onion. And if you were to pick up an onion, you would notice that you can peel the layers off one by one, right? It has a papery outer skin, and then you peel each layer off. And it's important to note that as you peel the layers off, they're discarded, right? They're gone. So that is what we're going to think about when we think of the dependency inversion principle, is that when you access the layers of an onion, you move from the outside inwards. To elaborate on that, this is an onion, okay? There are various parts of the onion. At the top, you can see the leaves and flowers. It's kind of cut off in my nice anatomical diagram, but you get the point. We have the outer skin. We consider that to be our application layer. And then once we peel off the outer skin, we get our inner fleshy layers, which comprise the majority of our business logic. And then right at the bottom, if you were just to keep peeling, you'd find that there's a base, and that's our core domain model. And then from underneath the base, there are roots, and that's how the onion gets its nourishment, and that is what we would consider to be the infrastructure. So let's start from the outside and work our way in and think about all of the layers of an onion one at a time. So the leaves and the flowers of an onion are the presentation layer. They're not really interested in much, but putting themselves out there, okay? Like flowers turn into seeds, and that's how our onion reproduces and shows itself and spreads itself around the outside world. Starting from this outer layer, it sort of has to be aware of all of the internals of the onion in order to operate, in order to give the user or the harvester of the onion what it wants. And a fun onion fact, because I'd like to intersperse this talk with my knowledge on botany, and onion botany in particular. Onions are biennial, so that means that they have like a 2-year life cycle. In the first year, they focus on swelling up and growing these big oniony layers that you eat, and then in the second year, they'll flower, and that's the reproductive stage. So that's what the point of an onion flower is. And you'll see this particular layer, this leaves and presentations layer, in things like HTTP routes and API entry points, GraphQL schemas, and also your templates like Blade or Twig or whatever it is, template engine you're using. So just so that you can identify this layer in your code, that's where you'll find it. The next layer we're going to look at is the skin of an onion, the papery stuff that you'd peel off and you wouldn't eat it. It facilitates safe interactions with the system, okay? You can't access the internals of the onion without going through this papery layer. In terms of monolith, as I like to call it, we're talking about the application layer. This is the part of the application that doesn't have much substance in and of itself, but it protects the inside of the onion from pests and diseases. That could be, for example, brute force attacks. We're going to say, no, this papery skin is here to prevent that kind of thing. And pests like malformed requests. And yes, so that is the purpose of the skin of an onion as well, is to protect the insides from things in the environment that you don't want to attack the tasty onion flesh. And the outside skin of an onion is actually called a tunic. Things that we might find in this layer in our actual application are controllers, commands, and service providers. They're the parts of our system that orchestrate things, that put things together, but don't actually contain any business logic themselves. Then, underneath our outer papery layer, we have the bulk of the onion, right? These fleshy leaves, as they actually are leaves, contain all the nutrients for our system. It swells as it grows. This is where we're going to find the bulk of our logic. But something to note about onions, which I find is also true in our big legacy monoliths, is that the layers are actually still separate from one another. I'll go into more detail about that later. But these layers are the implementations of abstractions. These are your classes, your services. And yes, as I alluded to, the fleshy layers that are the bulk of the onion are actually succulent leaves, so they absorb and store water and nutrients. And our big fleshy layers are our domain services, our helpers, processes, algorithms. This is, for all intents and purposes, your actual code. Moving on from that, we have the base of the onion. This is once we've peeled off all the layers and we're sort of just left with a little stubby, hard, dry bit at the bottom of the onion. This stem, it doesn't seem like much, but it contains all of the information required for the onion growth. This is the building blocks. These are the encapsulations, the abstractions of a monolith. And it's essentially our core domain model. We're talking about interfaces here. And yes, the base of an onion is a stem. It's just very short and very wide. it has a top, and all of the fleshy leaves and layers grow from the top, and from the underneath grow roots. So in this layer, you'll find things like entities, aggregates, and value objects, and I'm sure you've heard these kind of terms before when it comes to domain-driven design. But these are like the things that are the core concepts of your system. And last but not least, we have those roots. These provide nourishment to our onion from the outside world. They are our infrastructure. They support us. They support our monolith. So at this layer, you find things that aren't part of the business logic, but support it. This could be databases and things like that. They're very well hidden from the public. They're actually the outer layer of the onion. Like, you can access the roots of an onion just by turning it upside down. You don't need to peel any layers off. And that's important to note. The roots are on the outside, but they bring in information. They don't broadcast out information. Things in this layer are your ORM, your frameworks, adapters, SDKs, anything that is not core to your system and is brought in from elsewhere. So now that we know what exactly the inside of an onion looks like and what the various layers are, I'd like to talk about how onions actually grow. So this is going to be, okay, one thing about me is that I really like to take an analogy and run with it, okay? So you're going to have to bear with me, but I'm going to talk a bit about how onions grow in the context of domain-driven design. And it all starts with the ground. We plant onions in the ground. And before we go planting onions willy-nilly wherever there is ground, we have to think about what that ground looks like. Yeah, we can't just throw onions into concrete. It's not going to grow. So we're going to do a bit of surveying our domain. Haha, domain. The first letter in domain-driven design, okay? So this talk isn't, I'm not going to go into massively in-depth about domain-driven design. I just want to take these sort of core concepts of domain-driven design and put them into a language that's understandable if you understand onions. So when you're surveying your domain, and by that I mean talking to domain experts and business stakeholders and people that know what they want your system to do, you will determine a ubiquitous language. A ubiquitous language is the language that everyone speaks. It's understandable by everyone. So, for example, if we're talking about an HR system, let's say, we don't necessarily have people, we have employees. Yeah. So calling something a person is kind of meaningless in that domain, in that context. So figuring out what that ubiquitous language is a really important first step when thinking about domain-driven design. And we can also look into writing user stories about what kind of problems our users have and what our system aims to solve. And this is, doing that groundwork. So we know what our ground looks like. We think, oh yeah, that looks good. So we're going to start by planting a seed. And this, so a seed of an onion contains enough nutrients to sustain, the beginning of its life without needing to get nutrients from outside through its roots or anything yet. So it's very small and doesn't have much substance in and of itself, but it does contain all of the rules and information that's required in order to start growing. And at this stage, in domain-driven design, we're going to think about defining what our core domain concepts are. That means entities, value objects, and encapsulating all of that into what is our core domain model. I want to quickly and briefly explain what some of these things are. So an entity is something that has a life cycle. It is mutable, it is changeable. An entity can change over time. And that contrasts to a value object. A value object doesn't have an identity, it just is. And if two value objects have the same properties, they are, for all intents and purposes, the same thing. So an example of an entity might be an employee. An employee has an employment status, it has contact details, and it can change over time. But a value object could be something like that employee's address. Okay, the employee's address changes, but the address in and of itself, it doesn't change. A house has an address, right? If someone else moves into that house, they have a different address, but the address of the house is the same. So that's what we're talking about when we're talking about value objects and entities. And whenever you define these and create these, really think about the ground around you. What's going to make sense? That's where ubiquitous language that we defined in the previous step comes into play. And I think it's important to note at this stage that we're encapsulating concepts. These are interfaces, things that can be expanded upon later. And later being when our system germinates. Cool. Our system now has all of the information that it requires in order to start growing, and we start to implement our actual business logic. Taking all of the concepts that we encapsulated in our core domain model, we're going to write implementations of those at this stage. This is where our onion and monolith, and it grows and it swells. Cool. Onions, like I said earlier, and like I've said repeatedly, grow in layers, and each layer is independent from other layers. So when thinking about domain-driven design, we have the concept of a bounded context. Something that means one thing in one context can mean something completely different in another context. For example, we have a core concept of an employee in our domain model, our core domain model, but employee means different things to different people or different parts of the organization. When we're recruiting, an employee is potentially an employee, not yet an employee, to someone that's doing pay slips. An employee is an entity that we need to send money to. When doing other HR functions, you might need different information about an employee or do different things with them, or, so it's okay to have one concept in your core domain model, but different versions of it or different instances of it in different bounded contexts. So when implementing your layers of your business logic, it's important to consider those bounded contexts and have them not reference each other. They're separate. Everything can reference the core domain model, our base, or our seed, our encapsulation, but they can't reference each other. And that's how things are kept, decoupled, nice, separate, easy to understand. After we have the fleshy part of our onion sort of going, it's going to need more nutrients in order to keep growing. And that's where we think about our external infrastructure. And I'm sure that a lot of you have heard of like a ports and adapters architecture. So a port is an interface that something can plug into. And it sort of, how to describe this? It's something that is like, it acts like a contract. This is what we want something to do, but how it's actually done doesn't really matter to us. And we can write these ports for things like the storage layer, something that's not necessarily business specific, but nevertheless we need in order to support our growth. Adapters are things that implement that interface, and because we only reference interfaces, this is a solid principle, okay? So we don't reference concretions, we only reference abstractions, means that we can reuse things and re-implement things at will, and it won't impact our core domain or our fleshy inner layers. So that's something that's important to note, is this concept of ports and adapters helps with keeping our system decoupled. After our onion is growing and developing, we need to put a skin around it. These are what prevent things from coming at the internals without being adequately protected. So it ties everything together. It directs and determines how these interactions occur. These are things like controllers, which end up being use cases. They can be a lot more granular than what the user stories were that you had done the research for when you were surveying the ground. But ultimately, you sort of compose what this user journey looks like, how they come into this onion, and where that, which layer communicates with other layers, what abstractions are being referenced. And that's where service providers come in as well. So most applications and frameworks have some sort of container or service provider layer, and that allows us to orchestrate our dependencies. So say, what exactly infrastructure are we using to support this? How are we translating incoming requests? How are we parsing this? How are we transforming that? So that is our application layer. There should be no core domain or business logic within this layer. It's all about transforming and translating and protecting. And then once we have everything working internally, we can sort of show off to the outside world. Your system is built, it has grown, there are ways that it can do stuff, it can process things. So the final stage is obviously to allow externals to reach that, and that would be through your views or templates, your graphical user interfaces, and your API schema definitions and things like that. So hopefully that's given everyone a sort of quick overview of domain-driven design from using the onion analogy. But I can see that you're all sat there thinking, that's all well and good, Katy, but my onion's already chopped up, okay? I'm not building a new onion, I'm not growing a new onion. My monolith is there already, and it's a mess. It's been mashed up, and yeah, so how can I apply any of this to my big legacy monolith? And to do that, okay, as with all things onion, we have to master the elements of good coding. So we're going to talk about how we can work with our legacy monoliths and make them taste a bit better. And to do that, I'm going to refer to this great book / Netflix series by Samin Nosrat, who is a celebrity chef. And she says that the 4 elements to good cooking are salt, fat, acid, and heat. And that's true, because if you take an onion, okay, it's not very palatable by itself, but if you cover it in olive oil and then salt and put it in the oven at low and slow for about an hour, and then take it out and drizzle balsamic vinegar on it, tastes good. That's all you need to do to make an onion taste good. So we're going to look at how we can apply these 4 elements of good cooking to our existing code bases, and hopefully make them a little bit more palatable. And let's start with salt. Salt in cooking gives clarity to the flavors of an ingredient or a dish. It doesn't actually have that much flavor in and of itself. It just makes the food shine, And Samin Nosrat says, the 3 basic decisions involving salt are when, how much, and in what form. And this applies to coding as well, when we think about salt as being the naming that we use in our systems, the comments that we write in our code, the type hinting, the sprinkling of clarity. So to illustrate some examples of the kind of things that I mean, is when you have something like this. And it looks okay, but this information is duplicated, right? Because we already know what the parameter is, and we already know what the return value is going to be, what the return type is. And I've seen in code bases, especially ones that are quite old, where we didn't necessarily have this level of type hinting, where you have like a gazillion parameters and then a massive doc block above those, that function definition as well, that's like describing all of the types of all of those parameters, and that takes up a lot of space. And the worst thing about it is that it gets out of date because you change the name of a parameter or the type or something like that, but the comments haven't been updated to reflect those. So you have my permission to delete those comments and instead use proper type hinting. Only add a dot block comment when it's information that isn't obvious from the function signature. So in this case, for example, we have our function, and just pretend there's a body there, okay? If something goes wrong with our function, we throw a not found error. So there's a lot of arguments about, okay, should we throw an error or return a null value? That's a whole other discussion, okay? But the point is that if we expect a method to throw an exception, it's not obvious. There's no way to type hint that. So that's the kind of thing that really benefits from that bit of added clarity in the form of code comments. So we talked about something that needed a bit less salt. I suppose it was too salty. But this is something that probably doesn't really have enough salt. By that, I mean it's quite vague. We have a handler. Handling what? Well, looks like it handles a bunch of things, actually. We don't really know. And the property, okay, so our order has properties, but what are those properties? We don't know. Like, this is so vague, and we've had to add comments to explain what it's trying to do because it can't be understood by itself. It's vague. It needs a bit more salt. So let's see how we can sprinkle a bit of clarity onto this kind of situation. We can use better naming for a start. A name like handler or worker or processor or service by itself is meaningless. It doesn't mean anything. So let's name it what it actually does, and think about the ubiquitous language that we determined in our original domain surveying, or later domain surveying if this is something that you're coming to from, like, you've already got a system. And let's name our functions correctly, and only try and do one thing at a time, and be really explicit about the types that we're returning. So in this case, we've transformed our generic properties object, which could contain God knows what, into items, which is an array of items, and we've added a comment there to specify that this is it's not just an array, it's an array of item objects. That's really helpful, okay? And we have a new object, a new entity, customer. So we know that when we want to get the customer, we know exactly what kind of data that is going to contain. Great, that's a lot clearer. That's all the salt that we needed in this scenario. And here we have an instance of, okay, we do have salt, right? Because the dot block quite adequately explains what this function is expected to do. Okay, it returns a mixed type hint, but the comment explains that it will return a foo if the thing is successful, otherwise it's going to return a string error. And exactly what this method does, it does two things. It updates foo and then it emits an event. That's all the information that we need for that function. But it's not quite right. I think we could do a little bit better, make this a little bit clearer. We could give it a decent function name, and we can throw errors rather than just returning strings. We can separate this one big God method into multiple smaller methods. They're private methods, so their implementation can change, but the overall sort of use case is the same. And that makes it a lot easier to reason about. And it makes it a lot safer as well, because you can't pass something that is invalid in that situation. And I know that naming things is really hard, and it's really hard to change these kinds of things all at once. We have ways of doing it. I recommend, if there's something that is a core concept but hasn't been encapsulated, you can write really small interfaces for those core concepts, and then gradually move all of the functionality that exists in your big God class or whatever into smaller pieces, and then just implement those smaller pieces, because we can implement multiple pieces to make a whole. And aliasing as well. So if something isn't named quite right, like you have a class that's just called person instead of employee, you can always say use person as employee, and then reference the new naming so that people get used to that ubiquitous language. And it's a bit clearer what we're talking about in these situations. And also something I quite like to do in a situation like this, for example, if I've changed the name of a method, you can use a deprecated dot block. So create a new method with the new name, and then that new method calls the old method with the old name, and then deprecate the old method. Nothing's actually changed, but the new naming is available for people to use. And in most IDEs, it comes with a crossed out, like, don't use this. And you can write in the dot block what function people should be using instead. So that's just a really helpful hint for everyone. So that's salt. The next thing is fat. Fat tastes good, okay? Yeah? But too much, and it becomes stodgy, greasy, not really that pleasant. So when thinking about cooking onions, fat is something like, we want, yeah? But we don't want too much of it. So I'm talking about sort of bloat, code bloat, things that can be a bit more concise. So some examples I'm going to go through are like when we have methods that are redundant. You end up with files of get, set, get, set, get, set, and it's just kind of meaningless. We've got to think about, is it possible for our objects to become invalid or enter an invalid state? Are there things within our domain logic that conflict with one another? And when we're thinking about mutability, don't just think, oh yeah, this thing can change. Think about why it changes. So, again, I'm going to go through a few code examples here. Here we have a user object, and it has our getter and setters. And as I alluded to, sometimes you have these where it's like get, set, get, set, get, set, get, set, with every single property that could be set on your entity. But when we were surveying our domain, or when we thought about our domain, we realized that actually users must have an ID, and their ID never changes, right? So let's not do getters and setters. Let's just constructor inject it, and with this lovely constructor promotion syntax, which is newish, where we can say that these are the properties that are going to exist on our user. They're private, so they can't be accessed unless we are using a get. And they're read-only, so they can't be changed. And we can just get rid of our setters, and we can leave our getters in when there are things that we actually do want to be able to access. Cool. That keeps things a lot leaner and cleaner, less dodgy. And then we have things like this as well, a contact details interface. This is great, okay, because we've got a lot of information here. We've sort of abstracted it away. But there's a lot of string. It doesn't say anything about the format of that data. Like, you can't just have just a random alphanumeric string as a phone number. It wouldn't be valid. So when we see a lot of things like this, when there's like a, what do you call it, a scalar type referenced, it's interesting to think, actually, could this be a value object? And in this example of what to do, we've created some value objects. We have a new phone and an address, and those are value objects. And within those interfaces, we can specify the contract that, it's a valid phone number, and have validation functionality and things like that. And that also reduces the scope of our contact details class, because we've managed to consolidate or separate things out into individual component parts. And it's safer, because you can't just set a random string as a phone number for someone's contact details. So, although it's the sort of same amount of code, it's just a lot nicer. It works better. And then we have this sort of invalid state. Sometimes you create things and they seem like a good idea at the time, but when you actually look at it, it doesn't really make sense. Because here, okay, we can get and set a birth date, and then we can set and get an age separately. But that means that, in theory, I could set my birth date as something and then put my age in as 21. And no one would know. So, this object can enter an invalid state. So this is what I was saying earlier. If something can be changed, think about why and how things change. So you can set a birth date, but when you set a birth date, the age should be derived from that birth date. We shouldn't be able to set them separately. Makes it, not invalid. So we can't get an invalid person if we just have two methods. We have set birth date, because that's what we are using to set the age of a person. But perhaps in our domain analysis at this point, we realize we don't care about what someone's birthday actually is. All we care about is how old they are. So we don't even need a getter for the birth date. We only want to know their age. So we've completely got rid of two methods entirely. Great, that's a lot leaner. Then we have something like this, and I'm sure that this is a common pattern repeated throughout our code bases, where we have a status, we get the status, and we set the status. Again, thinking about why things change. Can we specify the life cycle of our entities? If we have a project, it doesn't just change state, okay? It gets published, and it gets archived. That's what changes the state. So we're not directly changing the properties of an entity. It's why and how they change. And then if you want to change the status in publish, that's okay. That's up to your domain implementation. It's not up to your interface. It's really easy to read. It's really clear. And hopefully, nothing goes wrong. So that's how we would keep our code nice and lean and clear and not stodgy and not get bogged down by things. Next up is acid. Acid is used to balance flavor. Something doesn't taste right if it doesn't have the right kind of acid in it, okay? Like, my husband called me over, taste this chimichurri, it doesn't taste right. What's wrong with it? I need more lime juice. Yeah, that's the acid. If something doesn't have the right amount of acid, it's going to taste wrong. So, in terms of our onion, we're talking about dependency management, okay? The right things in the right places. referring back to solid principles. We're going to depend on abstractions, not concretions. We're not going to reference specific infrastructure if it's not relevant at that place in the code. And to break these kind of rules of like what asset to use and when, you must first understand them. So again, we're going to go through a few do's and don'ts. So don't do this. This is a little bit more subtle, but you'll notice that in our example, we have an interface, but it's referencing a class. It's not referencing an abstraction. It's referencing a concrete thing. This is wrong because it tightly couples your core domain model to a concrete thing. It's the layers there are merged together. This is bad. We do not want this. We want our layers to be nice and separate. So we should always refer to our abstractions. And in this case, we've illustrated that there is in fact an interface for the thing that we were referencing directly, and we're going to just reference that interface. We're not going to reference our concrete implementation whatsoever. Another common example of this kind of layers of referencing each other is when we reference specific architecture, or not architecture, infrastructure. So in this case, we're referencing specifically MySQL in one of our services that, it's the service layer, it's the fleshy layers, but it's referencing something, it's referencing the roots of our application. This is wrong because then we can't change that. What if MySQL goes out of favor? What if that API changes? What if we want to update things or use Postgres or whatever? This no longer works, it breaks. We should only use things in the layer in which they're supposed to be used. We can't just traverse through layers, okay? That's not how it works. Instead, we create ports and adapters, and in this case, our port is a repository interface. Common pattern. Repository sort of acts like the boundary between our business logic, our domain logic, and the actual infrastructure that we're using. So yes, we can use a repository, and then we're only referencing those interfaces. We're not referencing the specific infrastructure. And this is a lot better. Okay, this is our repository interface, and we specifically named it. It's a MySQL repo. It's not a Postgres repo or a Redis repo or anything like that. It's specific to MySQL. That's okay, and it's in our infrastructure layer. Great. But there's a slight problem here, and that's the dependency injection, okay? We don't have it. We're creating a new MySQL connection actually in our constructor, okay? So that means that if we need to change it, we can't. And that's where, if we have constructor injection, we say what we need, but we don't know where that's coming from. We can change where that comes from in our application layer, in our service providers. A note on that, a really great tool that I learned about recently for preventing these sort of like layer leakages is depth track. In depth track, you can specify the individual layers of your application. You say anything with this namespace is in the domain layer, anything with this namespace is in the infrastructure layer, anything with this namespace is, it's all separate. And then you can tell it which layers are allowed to reference other layers, and it will look at your code and say, ooh, you're referencing an actual implementation in one of your interfaces, and that's bad, you should fix that. So that is a really great thing that I think you should all check out, is depth track. It's a dependency tracker. The final element to good cooking is heat. And when we're talking about the onions, we're talking about performing under pressure, okay? Like performing, when we apply heat to something, making sure that, it comes out good. Apply the right type and quantity of heat for the proper amount of time, and you will turn out vibrant and beautiful food. So some of you know that I'm like a massive fan of testing, okay? I've done other talks on testing, and you can find them on YouTube. But I just want to make one brief note about testing that it will change your life, okay? One, okay, you can use mocks, but please use them carefully. Because when you have something like this, and okay, it's not usually going to be this explicit, it's kind of hidden in all layers of the spaghetti, is that when you're mocking something, you're not really testing it. It's just kind of like it's still raw, okay? It's still raw onion, you're not testing it. So be careful about what you mock. Only mock things that you really have to mock. Things like API calls, external infrastructure that you can't access from within your tests. And better yet, don't mock anything at all. We have anonymous classes, and they're not new, they're old, okay? Where we can implement our core domain abstractions just for this test. So it's a better alternative to mocking because it ensures that this is like a more real-world scenario. This is what we're working with. So consider using anonymous classes over mocks. So I'm going to do a quick recap, then that's Charlotte. We learned about onion architecture, the layers of an onion, and how they're all separate, and how we move from the outside inwards, not from the inside out. We learned about domain-driven design, how onions grow, the ground, the roots, how we, bloom. And we also mastered some of the clean coding. Mastering the elements of good cooking makes everything taste better. I have been Katy. Please leave me feedback on Joined In. You can find me on Mastodon, not X, Macath at PHP Social. Thank you.